So in this video, we're going to talk about the classical alcohol dehydration. Now, anytime you see an alcohol dehydration, this is actually an E1 reaction, right? So this is your classical E1 reaction, right? Now, here's an example, and we're actually going to go through the mechanism. If we take any alcohol, in this case, this is an example. If you take any alcohol and you put it in any acid, so in this case we're going to use sulfuric acid, right? But this could be hydrochloric acid, hydrobromic acid, hydroiodic acid, any sorts of acid, we actually get the alkene. This is the product that we would actually attain. Right? Now, how does this happen, right? Anytime you see an alcohol and acid, what we really get is an alkene. Now, let's go through the reaction mechanism of this. If we take the reactant, in this case, and we take this molecule. Anytime you see acid, we really can represent acid in a simpler form, just writing H plus. So any sort of acid, whether it's hydrochloric acid, hydrobromic acid, sulfuric acid, phosphoric acid, any acid, we could essentially simplify it to H plus in solution. Now the first thing that occurs is that a lone pair on the oxygen comes and takes off the hydrogen. Right? So essentially what we've now formed is actually a water molecule. So we have an oxygen that has two hydrogens on it, and now has one pair of lone pairs, so this is an automatic positive charge. We still have our methyl group, and we still have these R groups on the other side of the molecule. Right? In the second step, the water molecule now leaves in solution. Right? So essentially, we've now formed a carbocation. So let me move this up a little bit. Essentially, the water molecule leaves in solution, and so essentially, we've now formed a carbocation. There's still the methyl group, there's the carbocation, and there's my R groups on the other side of the molecule. So there is my my carbocation that we have now formed. Now bear in mind that I have two hydrogens. I've only wrote one, but we have two hydrogens on that carbon. Now in the ultimate step, the water that we formed now comes in and acts as a base, takes off the hydrogen adjacent to the carbocation. As a consequence, we now form a double bond and we actually satisfy the carbocation. So in this case, here's our final product. Which we drew above. So that is your classical alcohol dehydration. And so anytime we have an alcohol in the presence of an acid, we're going to get the alkene. Again, in this case, the Zaitsev product or the more substituted product. Right? So let's do an example without. So let me delete this. But let's do an example. Let's do an example without doing the mechanism, right? So if you're given this on an exam, and we put this in hydrochloric acid, what do you expect to be the product? Well, the product here is going to be, again, your classical alcohol dehydration. Your product here is going to be the alkene. And you could actually go through the mechanism for this reaction, right? Now let's go through it essentially, right? So let's actually go through it because there's an hydride shift in this molecule, right? So again, if we take the reactant, which is an alcohol, we really use HCl, but really we denote this as really H plus in solution. The alcohol or the oxygen is going to come in, form water on the molecule. So now I have an oxygen that has two hydrogens, one pair of lone pair. There's my positive charge. The water is going to leave in the second step to form a carbocation. So from that, we now have this molecule as a result. We now have our generated carbocation. Now remember, we have originally one hydrogen on this carbon, right? So we're looking at a secondary carbocation. However, we talked about 1,2 hydride shift continuously. If I could get it on a tertiary carbocation, which is more stable, then that's what I'm going to do, right? So in this case, this hydrogen is going to come down and satisfy the positive charge, right? So this is a 1,2 hydride shift, right? And essentially, I'm going to get the positive charge now on a tertiary carbocation. So there's a tertiary carbocation, and now there are my two hydrogens which are now satisfied. The last step of the reaction, the water molecule again is going to come in and act as a base now, takes off the hydrogen adjacent, forms a double bond. Sorry, messing up my arrow, but forming a double bond there. And so essentially, the final product of this reaction is going to be, again, the alkene. So that's all for, again, the alcohol dehydration.